Hello and welcome to lecture 4 of the course. In this lecture, we shall introduce a formalism for writing models. Before we proceed, you can download from the link given in the description below all models, views, and controllers necessary for the current lecture. And the compressed file you have downloaded contains also many .sql type files, for example, modelstates.sql, and you must import these files in the database IC and create all tables necessary for the coming lectures, up to and including lecture number 8. We begin by comparing the code written in lecture 2 and to the code produced in lecture 3 by Yii. And in lecture 2, we had class company X that extends model, whereas in lecture 3, we had the class company that extends Activerecord. And when one sees the keyword Activerecord, straight away it implies that you have the public static function table name in the class that links the model to an underlying table in the database, and that table fields are automatically become the model fields. Now, if we compare the views of company X to the views of company, we see that in general the appearance of the views for company X was more satisfactory compared to the ones produced by Yii. However, company X of course misses the crucial index view, and in that we show the Gridview widget that offers data filtering and CRUD operations. And recall that Yii suggested that in case you wish to use the Gridview widget, you had to define an extra model, the company search model. Finally, comparing company X controller to company controller, the difference there is actually that ActionIndex is missing, and ActionIndex renders the index view. What we plan to do is to incorporate into company X all missing elements suggested by Yii in an elegant and structured way, so as to build a formal blueprint for writing models. Our efforts to introduce such a formalism are based on two proposals for coding Activerecord models. And the first proposal is what I call the database decoupling proposal. And it just says that the coupling of the database to the application must be restricted exclusively within the models of the application. And ideally, views and controllers should be unaware of the presence of any database. The second proposal is much simpler as a concept. It's called the states types proposal. And it just says that we intend to collect all possible state values for all models of our application into a single table. And the same we shall do for all possible type values. Let's look at the implementation of the states proposal. We'll have a single table that will contain all possible state values for all models of our application. And each record of that table will be characterized by a unique numeric ID encoding a particular state value. Furthermore, we shall use group keys that will be stored in each record of the table, and we shall create groups of related state values within the table. We shall use the Activerecord model states to represent the above table in our application. The same thing we intend to do for all possible values of the type and subtype fields of our models. And we shall use the model types to represent the corresponding table in our application. And here you see the structure of table model states. MSTID there holds the unique value for some state. It is a primary key of the table, but it is not auto-incremented, of course. The field MST group there denotes in which group of states this state value belongs. There. And finally, we have the field MST hex color, because we want each state to be color-coded as well. And notice the indices we have declared for that table. The slide shows the contents of table model states, and actually columns, model names, and color name are there to facilitate table maintenance and readability, and they are not used in the actual programming process. And here is model states itself. Model states extends the active record. It is linked to a table. It has a rule function, although this is not necessary, since we will not input any data through any input form of our application. It has 3 user-defined functions: the getColor, getVal, and getList. The 2 first are self-explanatory. Let's have a closer look at the third one. This one accepts as input a list of state group values and return all state values for each state group in that list. And a quick view of the contents of table model types. Model types is a simpler version of model states. And in the table, you see type values there related to the fields company type and company subtype. Next, we consider the decoupling proposal. What this database decoupling proposal states is that the underlying database should be transparent to the views and controllers of our application. And we require that any interaction between our application and the database should be restricted within models. And I think a major step towards this goal is to free our code from any naming conventions imposed by the database. So what is the problem in Yii2 and what is the proposed solution? In Yii2, we know that by default, table field identifiers are used as the active field identifiers of the corresponding active record model. To circumvent that, we introduce a mapping function that corresponds a generic identifier of our choice to every of these active field identifiers. Subsequently, views and controllers never use active field names. Instead, they use the mapping function with the corresponding generic identifiers. For convenience, we may also introduce a function that returns the active field value given a generic field identifier, and we call that latter function the AFV function. We see there the map and AFV functions for model company. Function map is a static function and assigns a generic identifier, actually a label, to every active field identifier. In other words, to every table field name. So you see how it is done there. The function AFV associates a generic identifiers with values of the corresponding active fields. That means table fields. and the function builds up as necessary. And you can see here how it is written. So the proposed formalism for writing models is based on the function map and the use of figurative constants, actually. The function AFV provides a handy shorthand notation for accessing the values of active record fields. What are the benefits of this formalism? If we adopt it, we free our application from any naming conventions imposed by the underlying database. And I think now by doing that, the coupling of the database to our application is now controlled by adjusting the map and AFV functions accordingly, plus the values of the figurative constants if need be. Also, the above approach brings in focus the paramount importance of the model element in the MVC programming paradigm. What are the implications of adopting the formalism? Quite simply, we have to change the way we write code for our models, views, and controllers. And we summarize the modifications in the table below. And we show there in each row what you should use in case you just want to refer to the identifier of an active record field, if you want to get the value of an active record field, or if you want to assign some value to an active record field. The second row is a bit of interest, because you can have the same effect either using the AFV function and without using the AFV function. However, it's a bit more verbose. In all the above, X is the actual active record field identifier, in other words, the column name of the corresponding table, whereas Z is the generic field name we have associated with X, actually a convenient label. Finally, a formal blueprint for writing models. And you see there, we start by declaring the model itself. Class company extends the active record. Then you have any figurative constants that you may use in the model, plus any fields of the model that are not active fields. Then you have the familiar functions, table name, rules, and attribute labels. Then you may define relation type functions. We shall see them very soon. Then you have the two newly introduced functions, map and AFV. And after that, you have all user-defined functions for the model, or user-defined methods. In the next few slides, we'll see how the newly introduced functions map and AFV change the code for model company. We begin by the functions rules and attribute labels. It's very easy. Instead of using actual table field names, you just use function map with a corresponding generic identifier. And here are some user-defined methods of our company model. And you can see how we have employed the functions map and AFV, plus the predefined methods of the active record class to write them. Another method of model company is the delete soft. I have included it there because I have given two ways that you can write delete soft. The first one is using the predefined method for ActiveRecords update all. And the second one, it's an SQL version for that function. Actually, you construct an SQL statement that you execute afterwards. And the result is the same. This slide shows the method duplicate for model company. What duplicate does is that it creates a duplicate of an object of the class and stores it in the database as a new entry. And if everything is okay, it returns the ID of this new record. And notice the use of the functions unset and is new record. Actually, duplicate is not used in the code we have provided, but it's a nice piece of software to have around. Since function model company is an active record, we may write functions expressing relations to other active record models of our application. And these relations actually reflect relations that exist between the corresponding tables in the database. Our model company, we have written three such functions: the getState, getType, and getSubtype. Notice the naming convention used to write the identifier of such of these functions. You always begin with the word get, and then you choose an identifier of your own. The first function states that any company has a unique state. The second function says that any company has a unique type. And the third function says that any company has a unique subtype. Notice how you use the predefined function has1 so that you can correspond to every company a single state through the use of the foreign key company state. Relation function identifiers can be used to write concise and elegant code. For example, if $x is a company object, one can write echo $x pointer type. Type is actually the function there, and then you get access to the type record corresponding to your object $x, and then you can refer to any field of that record. We proceed to apply our formalism in writing views. As an example, we just see the edit view for companies. Nothing very difficult there. We used the edit view of lecture 2 as a template to write the current edit view. And here is the part of the ActiveForm in the edit view. Before we consider how the formalism introduced affects controllers' code, I think that we must first discuss some general design techniques and principles that must be applied when writing controllers. And if we combine this with the notation formalism just introduced, I believe that application development and maintenance will become easier. The first principle that you should adhere when writing controllers is what I call the methods principle. And what it says is that in controller actions, you should never use object fit identifiers. Instead, you should always use objects and model methods. Therefore, each time you find yourself using object fit identifiers within a controller action, even assigning some value to an object field, you should stop on the spot and implement a model method to do the job. And here I give an example of what you should not do and what you should do there. And please have a good look at it. At first, that may seem awkward, but in the long term, you'll appreciate the huge benefits of the approach. The second thing is what I call the concept of grid programming, and that means that you should think and design your application mainly as a sequence of data grids via which the various actions available are called. And in our simple setting there, we have the table company. Table company is represented within our application by model company. And you, as Yii suggests, you have to have a model company search. And using these two, you can, through actionIndex of the company controller, construct an index view. And the index view is actually a grid of records together with some action columns. The action columns contain control buttons, so if you press the red control button there, you are led back to the corresponding action, in our case action delete. The record is deleted, and then you come back to actionIndex and just refreshes the index view. Before we proceed to write the code for actionIndex of the company controller, we have to define the Companygrid model. It is what Yii suggests as the company search model. And you see, I have written it very simply there. Class Companygrid extends company, has a public field called criteria, two functions, show active and show deleted, that set the criteria. And once the criteria are set, you call the function search. And what it does, it creates a query that finds all companies satisfying these criteria. And you return that query back as an object of the class ActiveDataProvider. Finally, the code for actionIndex of the company controller, it's very simple in structure. You use model Companygrid or company search in the Yii terminology, and using that, you create a data provider and then you pass that as a parameter to the render method that renders the index grid view, which uses the Gridview widget to produce a grid of records on screen. And here is the code for the Gridview widget in the index grid view. Notice how it is written there. I have the data provider, and then I don't have any filtering options in the grid since I have commented this line. I have not passed a search model as a parameter. However, each row may have a different color depending on the state of the company at the row. And you see how I can accomplish that, and then follow all data columns of the grid. In each data column, there corresponds a field of the model company, as long as this field is also present in the data provider object you have given as a parameter. Let's focus now on the structure of an action column in the Gridview widget. You have quite some options there. You can make the whole column visible, you can add a header, and you can make also some of the control buttons in the column visible by defining an appropriate condition. Here you see how you transfer control through the control button to some action in some controller. Notice that in case you have to pass parameters back to that action as well, here we pass back the ID of the corresponding company. You should always use the post method to do that. Finally, a quick look at the ActionCreate of the company controller. It's very similar to the one we have seen in lecture 2. The only addition there is the predefined method save. So when you say company save, it actually inserts a new record in table company. We conclude by presenting a formal blueprint for writing controllers. You start by defining all models that will used in your controller. You define then all libraries. Then comes the controller definition itself, class, company, controller, extends controller, the familiar function behaviors. Through the rules element, you just, the way it is written, you say that only registered users can access the actions of the controller. And through the actions elements there, you say that all actions of your controller that accept parameters, they will do so as long as the data you pass there have been posted. I think this is very important, so I repeat it to make very clear. Never forget to post controller actions that accept parameters. After the behavior functions, follow the rest of the controller actions. And our company controller in action now. Admin, enter our application. Let's go straight to the company menu. Let's go to the index. The data columns are there, the action columns are there. If I go through the controls in an action column, in the left-hand corner, you see the action identifier appearing together with the respective parameter that the action needs. Change the state of a company, and the color changes as well. Now the company is inactive. Delete the company. It's soft deletion, so it has moved to the recycle bin. If I go to index, the other two companies are there. Let's go to the recycle bin and try to permanently delete it. A warning message comes up, cancel, and let's restore it. So we're back there, and this is inactive. Have a view at it. Let's try and edit it. Okay. And let's have a look again at it. And let's try to re-edit it. And now let's try to edit another record, not through the grid, but through the address bar by changing the ID up there. And you see the post method has protected me. Back to the index. I have the new company is there working quite nicely. And finally, log out. Review of what we said. I think that this lecture is one of the most important lectures of the course. We have introduced a formalism for writing models that decouples the application from many naming conventions dictated by the underlying database. We have introduced the methods principles. Never forget that, that in controller actions, you never use object field identifiers. You should always use objects and model methods instead. Also, you have said that you should visualize your application as a sequence of data grids via which you call the necessary actions, and we call that grid programming. And finally, we had a close look at how the Gridview widget can be used. Many thanks for watching. Please subscribe, please support.